Hello everybody, and welcome to today's edition of our monthly webinar series. My name is Ben Crone. I'm a senior engineer at Arup, and I work with our software team to provide client support. In today's webinar, I will be going through how to create and position a seatbelt using Oasys PRIMER. Today's talk should last around 45 minutes, and if you have any questions as we progress, please enter them into the box, and if we have time at the end, I will try to answer as many as possible. Today's webinar is the first of a two-part series on belt fitting. We will begin with a brief introduction of the Oasys software suite and the purpose of Oasys PRIMER. Then in today's content, we will look at the seatbelt definition, how to create one, how to create a belt path and fit the path around our occupant and the structure. We'll look at how to mesh a belt and create a contact. So that's webinar number 1. And then in a later webinar, advanced belt fitting, hopefully in July, we will look at how we edit our seat belts, refit them, and some advanced features and settings. This is the Oasys software suite. We have PRIMER, which is our pre-processing tool used to assemble, edit, and check models. This is the software we'll be using today. It's currently in version 14, and that's the version I'll be using. There are some differences between our previous version 13 and version 14, and I'll try to highlight those along the way for those of you who are yet to pick up our latest version. In addition to PRIMER, we also have some post-processing tools. One is D3plot, that's our tool for displaying and animating results. We also have THIS, which is a time history plotting and processing tool. Then we have Reporter, which is an automatic post-processing tool for creating reports following different analyses. And Reporter brings together all three of the other software into one single package. So the purpose of Oasys PRIMER, it's a specialized preprocessor used only for LS-DYNA models. PRIMER's modeling tools and comprehensive error checking can reduce preparation and debugging time. PRIMER is fully compatible with the latest version of LS-DYNA, so no information is lost when reading or writing out of model data. PRIMER's model management tool allows the CAE teams to work in parallel on different components of the same model. Because of PRIMER's robustness and depth of understanding of the LS-DYNA data deck, users trust PRIMER to work on their complex models without corrupting or losing any data. The first thing we will look at is the seatbelt definition. Before we can create a seatbelt, or a seatbelt definition, we must set the current layer within PRIMER. This dictates which include file the seatbelts and the seatbelt entities will be created in. There are several ways to set the current layer within PRIMER. One would be to right-click an entity from the model window and from the drop-down select the current layer. A second way would be from the include panel where we right-click and include and then make it the current layer. And the third method, as shown on the screen there, is from the part tree. We can right-click and include, and then in the drop-down shown, the green button, we can make the current layer. And that tells PRIMER that any entities that are created as part of the seatbelt definition process will be stored in that include going forwards. A functioning seatbelt is not a single LS-DYNA entity. Rather, it's a collection of LS-DYNA elements and properties which together define a seatbelt system. And because there isn't a star seatbelt keyword in DYNA, PRIMER has stored the various tools for seatbelts within the tools menu. So those are the blue buttons at the top of the right-hand side of the GUI. Seatbelts is located in the safety drop-down as shown on the screen. When we enter the seatbelt definition menu, we are presented with the menu as shown. There are 4 stages to defining a fully functional seatbelt. Those are listed at the top of the menu there. So we have step 1, define, step 2, fit, step 3, mesh, and step 4, contact. And today we'll be looking at each of those in turn, going from a zero seatbelt state to a fully meshed seatbelt with contact. If there are no seatbelts in your model to begin with, the menu will look as it does on the left-hand side there. So lots of the buttons will be grayed out because they're not active yet. The first thing we would do is click the Create button, and that takes us to the second of those screenshots. Here we have the option of selecting the model to create the seatbelt in if we had more than one model read into our primer session. And we can also give the seatbelt an ID number. This isn't an LS-DYNA ID. It's used by Primer internally to differentiate between different seatbelts. So we might have a driver seatbelt, and we could also have a passenger seatbelt. The third option there is to give the seatbelt a title. So we might call one driver or passenger, and that's mostly for our own benefit so that we can easily tell which is which. Once we've given Primer that information, we have to select the entities that the seatbelt will come into contact during the fitting process. We can do this in a number of ways. We could select the entire dummy, we could select via sets, we could do it on a part basis, or we can do it on individual elements. I typically use parts, and I try to select the least number of parts as possible. So for example, in a complicated occupant model, there might be lots of forms, and those forms will often be coated with shells. I would just select the shell coating, often a null coating, rather than the solid elements themselves. And this just makes the definition a little bit more simple, and it makes things a little bit more efficient when we do the fitting process. Primer's not having to consider quite so many parts, and we'll run a lot quicker. Once we've done that, we're taken back to the original panel, and you can see that all of the buttons are now active, and also down at the bottom we have a couple of buttons, add and remove, and that's so that we can return to this panel and add additional parts. Say we forgot one, or we added too many and we want to remove some parts. So we can do that from this panel too. And it's worth noting to also include parts on the seat scope or any structure that may be in contact with the belt, so that those are captured during the fitting process too. So as I mentioned, the seatbelt is not an LS-DYNA keyword. It's a Primer construct, and as a consequence of that, it's not stored with the regular LS-DYNA data. So in the screenshot there, this is a text editor of a sample keyword file. LS-DYNA would stop reading at the top of that screenshot there at the star end keyword. So similar to a dummy tree, Primer saves the seatbelt information after star end with its own syntax. So we've got star belt start, some seatbelt data, and then it finishes with star belt end. It's not expected that the user would edit any of this information, but it's worth knowing where it's stored in case, as you use your keyword decks in other preprocessors, or in text edit yourself, to make sure that this data doesn't go missing. Otherwise, Primer will no longer know about the seatbelt definition itself. So once we've created our seatbelt definition and told Primer which parts are going to be in contact with the definition of the seatbelt itself, we have to define the belt path. And this is the path the belt's going to take around our structure and over our occupant. And we do this from the second of those buttons in the seatbelt panel. So number 2, fit. And as soon as we click that button, we'll get a large pop-up with some fitting options. We can ignore that for the time being, and we will discuss it in more depth later. So I'll just show you a quick demo of where to find these menus and also the pop-up that we get. So this is my sample model here. Quite a basic setup. We have an occupant sat in a seat there. We've got a single B post and some floor elements. So I would go to safety, seatbelts. I already have a definition created, so all of these buttons are active. And then when I click fit, you see we get this fitting options panel, and this has got lots of useful information for as we progress through the seatbelt fitting process, some of which we'll discuss today. Others we'll return to in the future webinar. For the time being, I'm going to minimize that and continue to work with defining the seatbelt path. So the first thing we do in this menu is the red button there, define path. And this takes us to a path selection menu where we start to build up the path the belt is going to take around our occupant. So eventually we're aiming to get something like that's on the screen. At the moment, we would start from one end of the belt to the other, typically the retractor, up to the shoulder slip ring, 1 or 2 points over the chest, down to the buckle, and then back over to the pelvis, 1 or 2 points on the pelvis, and down to the floor. The way in which we do this is by selecting nodes in our model. So here we have 9 points selected, 9 different nodes. If we just go through each one in turn, the first one I selected then was at the base of the B post. So I selected a node and my structural mesh to define that endpoint. And the next point is up at the top, so a second node on that B post. Primer recognizes that this is an acute shape with the third and fourth nodes. We'll talk about what that means in a moment. Moving on, I select 1 or 2 points over the chest to get a nice clean path. A 5th point at the buckle. Again, Primer flags this one as an acute point. And 2 points over the lap. And then I've got a point on the seat squab. And that's just to prevent the belt clashing with this quite wide seat I've got. And then finally 1 point at the base. And our aim here is to start off with as fewer points as possible, keeping it nice and simple, but building up the number of points as required to make sure that we have a nice, sensible looking belt path and one that doesn't clash with any structure or the occupant. Once the basic path has been defined, the next step is to define the types of point and to tweak and modify the positioning of the belt. So the first step is to update the point types. There are several types available to us and they're listed in that second column in the menu panel. So the first column is the point numbers, and then the second column denotes the types of point we have. So in the drop-down list there we have unfixed, retractor, slip ring, B-post slip ring, meshed slip ring, fixed, known position, and then cross sections, which are in addition to the basic type. So I'll just go through each one of these in turn then. So an unfixed point, this is the default for any intermediate path point where the angle is not acute. And those are free to move during the form finding process. So this is when we pull the belt tight around our occupant. So these are starting points for our belt prior to the fitting process. We have the retractor, so that's where we're going to create a retractor element, often the first point in our belt. That's why I have there as point 1. We have free slip rings, B-post slip rings, and meshed slip rings. So the difference between those is that with a B-post slip ring versus a free slip ring, the primer is presuming that one side will be straight and stretched towards a retractor, and it constrains the rotation of those slip rings. The free slip rings are free in terms of their rotation and how we can orient the position of the belt at the slip ring, and a meshed-in slip ring is something else entirely that we'll cover in a moment. Fixed points demarcate the end of any attached segments, and the path is discontinuous at those points. A known position is not something we'll use today, but we'll come to it in the future webinar, and that's where we can force primer to fit the belt through a known position, and that's useful for child seats and very tight geometries. And then cross sections we'll look at it again in a moment. So with the cross sections, it's possible to add database cross section requests along a belt. This is done via selecting the X cross section. So this is in addition to the point type itself. A little X will appear in the corner there to signify this, and it's the reason that we may want to have some cross sections is to measure the forces in our belt, but often we don't want to measure the forces exactly at the point that we've used to define the belt. So that would be a slip ring or maybe an end or a retractor. So we're able to put in an offset for those database cross-sections from the given point. And those cross-section offsets are identified using the cross-section offsets button, which is in the main fitting panel. So that's in the small picture at the bottom there. I've highlighted the Xsect offsets button. If you go to click that, it takes us into the options for offsets, where we can provide different distances of offset for different types of point. So once we've selected our different types of point, we've input a retractor and changed our acute angles to be slip rings. The next step is to modify the path shape. The initial path is often quite sensible, but we'll need some tailoring. And this is done using 3 different buttons in the Define Path menu. So we've got Modify Coordinates, Twist, and Projection. This is actually a slight difference to version 13. In version 14, we didn't have the Projection button. We just had Modify Coordinates and modifying the twist. So I'll have a look at each one in turn now. Modifying coordinates allows the user to drag the points on the screen along the X, Y, and Z axes using the left, middle, and right mouse buttons, respectively. So in the example I've got there on the left-hand side, the lap portion of the belt is intersecting with the hip of the occupant. So we need to remove that intersection before we can fit the belt around the occupant. And the easiest way to do this would be to modify our points such that they're higher in the Z-axis. So we could select a different point, or we can right-click once we're in the Modify Coordinates mode. We can right-click one of those points on the screen and just drag up in Z. And that's what we've got on the right-hand side there, so we now have a no-clash condition. The second tool available to us then is the twist button, and then when we're in the twist mode, we get little cyan handles on each of the points, and we are able to click those handles and drag them around to change the twist of the belt. So we might want to do this to avoid a crossed edge, an intersection, or we might just want to do it to make the belt path more sensible. So in the example I've got here, it's not a clash with the structure or the occupant. This is a belt-to-belt clash that I have at the buckle slip ring, and you can see on the right hand side there, I just rotate that cyan handle around slightly, maybe 5 or 6 degrees, and we have a no clash condition there. And then finally, and this is the new to version 14 tool, is the projection mode. And this allows us to change the amount the belt is projected away from the points. So what you see there is the dark blue points are those that I've clicked to define my belt path, And Primer wraps the belt loosely around those points. And the default for that is 35 millimeters. So the belt is located 35 millimeters from the point that I select. This projection mode allows us to change the 35 millimeter default on an individual point basis. So that when we're in this mode, we get little arrows defining the projection vector. So you can see those in cyan on the screen there. And then I would select one of those points, click it with the mouse, and I can drag my belt along those arrows, changing the amount of projection at each of those points. And the reason we might do this rather than just move the coordinates themselves is as we drag the belt points around, after we drag them so far, they lose their relationship with the original points. So what we see in the menu shown on the right hand side there is that points 1 and 2 we still have a node assigned, yet 3 and 4 where I've moved those, that's now showing a 0 value. So that means that Primer's lost the associativity between the point and the node. And for a single belt definition that may not be a problem, but if the belt's likely to be refitted and modified in time, and these are things that we'll look at in the future webinar, it might be better to keep those nodes associated so that we can quickly rebuild the belt more easily in future. So projection allows us to modify that projection vector without losing the node association. And that's new in version 14. So before we look at the other tools, I'm going to jump into another demo. So here we have a belt that's already been fitted. So this is the same one from the demo there, from the slides. And if I go into define path, you can see those are my 9 points, some of which have lost their association to the original node. And if I go through each one of these in turn then, so modify coordinates, you can see as I hover over number 4 there, point 4, it turns red to let me know that I've clicked it. And then if I use the left-hand mouse button, I can move it in the x-axis, the middle mouse button in the y-axis, and then finally the right mouse button for the z-axis. So that's a nice way of being able to quickly adjust the belt path. With twist, you can see we have these little handles here, and then I can rotate the belt. And once I've done that, they turn from dark blue to cyan. You can see I'm able to rotate the belt around, and I could do this at each of those handles and then modify the belt path accordingly. And then lastly is the new for version 14 option, is projection. So you can see I haven't used this to set up my initial belt path. All of my distances are the default 35 millimeters, but again, if I use 0.4 as the example, I hover over the arrow there and we can see that that projection vector is changing, the magnitude of that, the distance is changing as I drag. So that's how we can modify our belt. And the goal at this point is to make sure that we have no intersections between our belt itself and our structure. Any crossed edges at this stage are going to snag the belt when we try to fit it around our occupant. You can see here when we do this projection, we also get a little small P there, and that's just to note when we're in other menus that we've changed the projection of that point. There are some other tools in this panel. We've got translate, rotate and scale, and they apply to the path as in its entirety. So reflect there as well at the bottom. That may be useful if you want to quickly go from a driver to a passenger definition. We can take one and reflect it to create a starting point at least for the other. And then sometimes for complex routing we might need to add additional points to generate the desired path. We've got 3 options highlighted there in the second picture, those green buttons. We've got the first one, IBE, so that's insert before. I AF, insert after, and then I at P, which is insert at point. So that allows us to insert new points before or after existing ones, or at an intermediate point. So I'll just quickly show you what I mean by an intermediate point. So when I click this button, you see Primer's got lots of little green points, and these are intermediate points that Primer is using to define internally the path of the belt. We can insert a new point at any one of these by just clicking it where it's shown in red there. That's a really convenient way of quickly adding new points along a belt. In general, I'd say fewer points are better to avoid over-constraining the fit process. So we've got 9 here. For a more complicated fit on, say, a child in a child seat, we might have over 20 different points, just to make sure that we get the path that we require. But in general, I'd say start with as few as possible and then build it up as required. Once you're happy with the points you've selected, the types of point and the path, we would save the belt path with the save button at the top there. So that's big red button as highlighted on the screen. When we do that, it drops us back into the original menu. So we're now at the stage where we could fit the belt, but before we do that, I want to run through some of the options available to us in that large button, that large panel that we minimized earlier. So at the top of this big panel, we've got 3 large buttons: Adult Preset, Child Preset, and General Preset. And the selection of those 3 buttons doesn't actually change the behavior of Primer itself and how it fits the belt. What those 3 buttons do is they change the settings within the rest of this panel. So it's the other settings on the panel that's changing the behavior. These 3 buttons at the top just give us a head start at selecting the best combination of settings for the type of belt that we're working on. So the default is an adult, and that's what I'm doing at the moment with our demo. So that's selected there, and the rest of the options are then based on what we think will be the best settings to create an adult seatbelt. We're going to look at a few of these settings at the moment, and then the rest will be discussed in the future webinar, hopefully in July. One of the options that we discuss now then is that the path order. So this is the shape that the belt takes between the different paths. So by default, it's a spline shape. So that's a smooth, continuous belt. Linear gives us straight lines. So that's the difference between the 2 pictures there. And then mixed is an average of the 2. I think spline generally gives the best result, especially for an adult belt. So that's what we're using at the moment. This panel can also be used to set the dimensions of our belt or the belt elements. So the default is shown at the top there, and that's what we're starting with our belt. We had 50mm width, 25mm length, so that's the element length along the belt. We've got the belt thickness as 1mm, and then the number of elements across the belt as being 1. So that's what Primer is showing in white there. So that's not elements yet, but it's where the elements will go when we mesh the belt. We can use this panel to change that. So that's the picture below. We've changed the belt width to be 60, made it slightly wider. We've changed the belt length to be 10mm, so that's why we get a lot more elements along the length. We've left the belt thickness the same, and we've got 5 rows across. That's what Primer's now drawing in the black and white there. It's also possible at this part of the menu to provide Primer with a parameter, and that Primer will then store in that parameter the length of the belt, either the total length of the belt or on a per segment basis, which may be useful for you. There are several options for changing what is displayed from the panel as well, and this can be useful when trying to determine the path around a complex occupant, or to establish whether any intersections have been introduced. So for example, we can change the display of the belt itself. We can draw the belt as a skeleton wire, a thick wire or thick shaded. So the two pictures on the left hand side there are showing the difference between thick shaded and skeleton. I like thick shaded because it helps me spot for any penetrations with the belt and the structure. And then also what we can do is we can display only a single segment of belt at a time. And what we mean by segments is shown in the little picture at the top right there. So it's stretches of belt from the ends and between slip rings or acute point types. So we've got, for our adult, we would have 3 segments. Segment 1 is shown in red there, and that's from the retractor up to the shoulder slip ring. And segment 2 is across the chest in green between the 2 slip rings. And then segment 3 is the lap segment, and that spans between the buccal slip ring and the floor. So in the example we have here, I've chosen to show only segment 3, and that's why we can only see the lap portion of the segment of the belt. It's not on the options panel, it's from the main belt fitting panel, where we can also change the way that the path is drawn. So this is the path that we've selected by clicking our nodes. And that's those 4 radio buttons there. So we can turn it off entirely with none. Basic only would be the blue points as shown on the screen there, and then the little black dotted line behind it that you can just make out. Current only is the white belt, so that means the current mesh essentially if we were to mesh the belt. And then basic and current is the default, and that just gives us all of the information that we need for our belt. And then lastly, by default, when we are in the seatbelt fitting mode, structural shells are drawn showing their true thicknesses. And this is to help us identify penetrations more easily. But should we want to, we can control this using the options on the fitting panel. And that's in the Draw Structural Shells As section, shown there at the bottom right. And we've got 3 choices. We can draw the thin nodal plane only. So that's the default view of primer when not seatbelt fitting. And then we've got 2 options for showing the true thickness. So we've got a flat version and a smooth, and that's just the difference in how primer treats the ends of the shell elements. So with smooth, it smooths out the edges to give a more realistic appearance. That's why it's the default. And I like to leave that on along with the thick shaded belt to really help identify any penetrations in my belt before and after the fitting process. So once we've set our parameters and they're happy with the belt fit, with the belt path, we would fit the belt around our occupant. So we do that using the red fit button as shown on the screen there. And I'll do this in a demo now. So I would, first of all, I would save my path, and then I would press the fit button. So I just change the view so you can see what happens. And I press fit. Primer's pulling the belt towards the occupant. It's a little bit slow now with the broadcasting the webinar. Hopefully it'll be a bit faster for you guys. If you see the belt going wrong, you can press stop at any time. So if we see it's an iterative process, I'm on 725, 750, 800, I can press stop, and then it's stopped there at iteration 885. I can inspect the belt, and if I press fit again, we start again from 885. The default would be 2050 iterations from the point that you press fit. So I've done 1200 now. I'm going to stop that. I think it's pretty good for the demo. And what we can see now is that we've got this fitted belt. And at this stage, we should be inspecting our belt for any crossed edges. So often around the lap we may have problems. We have some contact here, so we should check on the squab, over the chest, and then the shoulder too. You can see down here, the buckle has got a crossed edge, but we didn't actually select the buckle as part of our definition, so Primer wasn't aware of that. And actually, I don't care about the buckle in this particular model anyway. So that's been a success. However, it wouldn't always be a success. It's often an iterative process to get a belt fit, and what we do in this case, for example, if we had some intersections, some crossed edges, like we have in the picture on the left there, what we would do is we would go back to the defined path and modify our points. So in this example, the belt is being pulled down, and then as the belt slides forward on the lap there, it's getting snagged on those small null rings connecting the thighs to the hips of the occupant. It might be that we didn't define that and we need to go back to our definition and add those small parts, or it could just be that Primer's having some trouble handling that contact, and we can fix that by moving those 2 points forward in X, which is what I've done on the right hand side, and then this time as the belt gets pulled tight, it's pulled backwards over those, and we have a nice clean contact condition as we have in the demo I've just clicked, and then also on the right hand side of the picture there. So a little note about meshed in slip rings now. These were added in Primer version 13, and it's the ability to add a slip ring that relies on contact using shells or solids rather than a star element slip ring entity. So in the current example, if we had have wanted to use a meshed in slip ring, we could have selected it from the defined path submenu. So that's the M type, the mesh slip ring type. And then on the right hand side there, we've got the options for those meshed in slip rings on the fitting options panel. So there's 3 inputs there. We've got radius, angle and transition distance. And Primer doesn't actually need the mesh for the slip ring. It doesn't use it. What Primer does is it creates an imaginary cylinder to wrap the belt around, and that cylinder is of radius as defined by this panel. So here we would have a radius of 5 mil. Then Primer bisects that cylinder with a given angle. So we would break that cylinder down in 15-degree increments, and the distance along the outside of the cylinder as broken by the angle dictates our element length around the meshed in slip ring. So we need more elements around the slip ring than we would normally have to make sure that we can capture the curvature. So then we have a fine element size around the slip ring as defined by the element angle, and then that transitions from fine to the coarser default values for the belt over a given transition distance. So I've got a picture of that here. On the left hand side is prior to fitting, on the right hand side is post fit, and we can see that the Primer's drawn the imaginary cylinder in there, and then it's also got this fine transition area to make sure we capture the curvature. In our current example, we'll continue with the regular star element slip ring. So once we've fitted our belt and we've inspected it visually, we're happy that it's the path that we want. We need to mesh it, and to do that we must accept the definition. So that's what we have highlighted there, the accept button. When we do that, the fitting panel closes, and we move on to step 3, which is the mesh button. And this is taking our black and white version of the belt as drawn by Primer and turning those black and white elements into proper LS-DYNA elements, not just visual representations as they are currently. So just a little slide on the meshing panel itself. It's changed slightly in version 14. So at the top left there we have a button O/N, and that's for old and new style. So the new style is shown there, and it's this grid of element types for each segment. And we'll discuss that in a moment. Beneath that we have 3 buttons for the element properties. So there's the part cards that we're going to use for our 1D, 2D and shell elements. Right of those we've got a little schematic showing the segment of belt that we're currently working on. So the example there is the first segment between the retractor and the shoulder slip ring. Primer's telling me that there's going to be 68 elements, and I haven't yet defined the seatbelt part. And at the bottom there is the labeling controls for the entities which will be created. So Primer's going to create lots of new entities for us once we press the mesh button, and this just tells Primer what labels it should be using. So using the old style then, there are 5 element choices and configuration types that we had available to us. So that's shown on the screen there. So we have 1, 2, 3, 4, 5. We have number 1 would be one-dimensional seatbelt elements only, so 1D seatbelts. The second choice would be 2D seatbelts. So only 1D and 2D seatbelt elements can pass through retractors and slip rings. So they need to be used for those at those points of our belt. In between those points we could use shells, which is the third option there, shells only. And that's just using shell elements, star element shell with more than likely a fabric material property. And then finally we've got 4 and 5, which is a mixture of 1Ds and shells and 2D seatbelt elements and shells respectively. So that's the old style of the menu. In version 14 we've adopted this matrix, and what this allows us to do is to combine different types of element for each segment. So we can have a mixture of 1D, 2D and shells within the same segment, giving more complicated definitions than what was previously possible. And what you can see there, for example, is Primer is not letting us select the shells. That's the third column there for the ends 1 or end 2, because that's where we have some slip rings. Well, sorry, that's where we have a retractor and a slip ring. So Primer's put a cross through those to tell us that we can't use those types of elements at that point. If we were to create a combination of elements that was not valid, Primer wouldn't let us generate the belt mesh, so it should never be possible to create something that's not legal within LS-DYNA. So in this example we'll use basic 1D elements and then shells across the occupant, and by default Primer will create these elements for us, the elements for the belt, but also the retractor and the slip rings. If we don't want Primer to create those, we can select the retractor and slip ring buttons as highlighted on the screen there in the menu screenshot. That takes us into a submenu where we have a choice of defining an existing entity within our model. So if we already have a retractor or a slip ring element and we want to reuse that, we can identify this here at this point. So for over the chest and the lap, we're going to have a combination of 1D and shells. And it's worth noting here that we can change the amount of elements we have on either side of the slip ring with the little text entry box on the schematic area of the panel. And it's important because too few elements would result in an error termination if the shells reach the slip rings. So the default there is 4 elements. In this example I change it to 8 to be a little bit more conservative. And then similarly for the lap, the final lap segment, I've changed 8 on the buckle slip ring. You can see that in the box more clearly now. And then at the end 0.9 segment at the floor, I've changed that to, I've left that as 4 because I'm not worried about those passing through any slip rings or into a retractor. Once the mesh parameters for each segment have been defined, the next stage is to input the properties of the parts to be meshed. So that's the part IDs and element specific properties. So in our example here, we're using 1Ds and shells. So those 2 buttons have turned red, and the red signifies that we haven't defined any properties. So if we clicked each of those in turn, we get the panels as shown there. The 1Ds are on the left, the shells are on the right. We give the Primer the part IDs in the top section of each panel. We have to create these in advance. Primer doesn't do this for us. And then we put in seatbelt specific properties on the element specific properties in the lower part of the panel. So we've got a slack length for 1D seatbelts, and then the regular underscore thickness underscore beta options for shells. And Primer would apply those properties to each element that it creates. Once we've given Primer all of the information it needs and selected the entity types that we want, the generate button should be active, And when we click that, so that's the red button towards the bottom there, Primer will mesh our belt. And the first thing it does is gives us a pop-up telling us exactly what's been created for each segment. It then moves on to a summary, and it gives us a list of the different entities in our belt, and also it's the status of any checks it's performed. So in this example, everything's looking okay, except we've got some errors with the retractor. So if we were to click that retractor button, it would open up the retractor element card. And then from there we can see immediately that there are some red fields, so that needs some input from us, from the user. But if we wanted to check the definition more thoroughly, we can click the check definition button in the top part of the panel. So Primer's already told us that there are 3 errors and warnings, but we don't know what they are. When we click that button, we get a new error, a new panel that tells us that we had an error with the fed length, so the L fed parameter, the loading curve. The warning was about the unloading curve, and then we also have an error because the sensor was not defined. So we can dismiss that panel now that we have some more details about our errors and work towards correcting them. So that's what we've got in the right-hand picture there. We've inputted the sensor, the 2 load curves, and also a fed length. And now when we update that element, Primer tells us that the checks are okay. So the red retractor button is now turned grey. It's worth pointing out that this summary panel can also be used to check or edit other data, not just those that have been flagged as containing errors. So we might want to do that with the slip ring. Although those checks are okay for each of the 2 slip rings, Primer hasn't been able to fill in any of the other data that we might want to put in. So we can do that at this stage also. So we can click a slip ring, go to the panel as shown on the right hand side there, and then I've entered in the Coulomb friction. So that's the top value there, FC. I've given a value of 0.2. By default, Primer would have left that as 0 because there's been no stage in the seatbelt creation process for us to define any of these properties. So once we've corrected any errors, our belt has been fitted, we've meshed it. The only thing left to do is to define a contact. And this is an optional stage of the belt fitting. You may already have the contacts defined in your model. But because Primer has an intimate knowledge of the elements of the belt and the parts that you selected to come into contact with the belt, we can use that to quickly create belt contacts. So that's the 4th and final stage of the fitting process. So if we click that, it brings up the panel on the right-hand side there. And we have 2 options available to us. We can create an automatic nodes-to-surface contact or an automatic surface-to-surface contact. We can also input the contact parameters using the buttons on the right-hand side there, and we can open up the full contact card should we wish using the large edit full contact parameters. Well, all we would need to do is click one of those. So in this example, I've clicked the automatic surface to surface. Primer creates that. The belt would become the slave and the structural parts the master, and then I can edit it or delete it if I'm not happy with it. But that's been created and using the inputs that I've already specified. And now with the contact created, the belt definition is complete. We've identified the parts to come into contact with the belt itself as the seatbelt definition. We've defined the path, we fitted the path, we've checked for any intersections, then we meshed the belt. Once the belt was meshed, we were able to create some contacts, and now we are free to dismiss this menu and save the model or the individual layer as required. And with that, it concludes today's webinar on Oasys Primer seatbelt creation and positioning. It's the first of 2 webinars on seatbelts. The second webinar will follow in July, and we'll look at how we edit the belt once it's been created, how to refit it, how to change dummies, for example, and then also at the more advanced settings and features for doing more complicated belt fitting, such as child occupants and child seats.